Um, I would like to briefly go over the significance of this three-part array of numbers that achieves a magic hybrid cube a lot faster than actually doing it on the cube itself. And this cube is not represented by these array of numbers, these three-part array of numbers, because, well, for instance, the 5 is not the central real number of this. This is the central real number of this is 3. But all the others, the 3 input primary numbers, 1, 2, 3, are the same. But this is the central real number of 3. This is the central real number of 5. Okay, starting out, this whole 3 by 5 array I call the primary number intersecting matrix. And how you get that, you just start out with the 4 numbers that you're capable of dealing with, 3 input primary numbers, in this case 1, 2, 3 in blue, and the central real number in 5. You give 5 to all these because these are 3 intersecting equations. 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8. And with the commutative property, it's 11 on both sides for this, 9 on both sides for this, and 7 on both sides for this. To derive the secondary number planar matrix, these are the lines of equations for the secondary numbers in orange, and they don't intersect the central real number. They bounce off, sort of. 3 bouncing off 3 equals 6. And then it continues. 6 bouncing off 3 equals 9, the output. And in the back, in the reverse back here, 3 bouncing off 3 equals 6 back here. 6 coming up here and bouncing off 3 equals 9 over here. Same thing for all these split apart equations. And there's a green pen marks out the horizontal plane. Brown pen marks out the front to back, or vertical plane, and yellow pen marks out the face on equations that bounce off the 3, or the equals added to the 3 equals the number it reflects onto. So that's a secondary planar matrix or array of numbers. And how you get this secondary planar matrix? You find the combinations of 1, 2, and 3 in 2 pairs each. Like 1 plus 2 is 3, 1 plus 3 is 4, and 2 plus 3 is 5. Those are the only combinations you can have. And then you still give it the central real number because they bounce off there. 3 plus 5 is 8. 5 plus 5 is 10. 4 plus 5 is 9. And then you bring down the central real number again because it bounces off again. There's 2 equations on each plane that reflects off to give the final output. So you bring down the central real number again. 8 plus 5 is 13. 10 plus 5 is 15. 9 plus 5 is 14. And then you do the commutative property on both sides, 16 and 16. Or 3 plus 13 is 16 and 16. 20 is from 5 plus 15. And 18 is from 4 to 14. And then you bring these outer commutative property numbers, bring them down from the primary and the secondary numbers matrices. You add them, you get 81 for the outer ghost number of this particular cube. and then you put 81 on both sides. And to derive this final inner and outer diagonal matrix, ghost number matrix, you add these primary numbers to, or you add these primary numbers to these secondary numbers to get the 18, or to get the 48. Then you add these primary numbers and secondary numbers to get 18. And if you know the rule of the way that these structures are built, you know that that it only has one case of a one larger to smaller to larger number. The rest of them are duplicates. So this is the end result of the diagonal matrix of the inner and outer ghost numbers. These are the inner ghost numbers, and it's a combination of this method and these methods. Well, I hope I explained all this a lot, or good enough. Thanks a lot.